Welcome to our series of learning modules that focuses on the value of research in patient care. Our objective is to educate clinical staff on the scientific method and how to apply it to everyday clinical practice. In this, the first section of Module 4, we will explore how to effectively present study results in tables and graphs. In this module, we will offer general guidelines for selecting a table or graph, give examples using the clinical questions from Module 2, and provide sample write-ups for study results. You may be wondering when to use a table versus a graph. In general, a graph is preferable when you want to present many data points, and a table is preferable for a few data points. A graph is also preferable when you want to show rates of change or trends in data, or the statistical distribution of data, whereas a table is preferable for describing qualitative variables. Before we give examples of tables and graphs, you'll recall that in Module 2, our first clinical question focused on the influence of two variables, sodium intake and physical activity, and how a decrease in one and an increase in the other could lead to changes in patient blood pressure. We will use a prospective study design, and our outcomes will include average daily blood pressure and physical stamina. Our metrics will include average systolic and diastolic blood pressure values and average stamina in minutes. The first table summarizes illustrative demographics for the two groups: standard sodium and self-directed exercise versus decreased sodium and increased exercise. We see patients' mean age, mean body mass index, and the percentage of males and females. The second table summarizes illustrative results from an independent samples t-test. We see that Group 2 showed a significant decrease in ending mean systolic and diastolic blood pressure, an increase in ending mean stamina, and an increase in ending mean range of motion for knee flexion. The first graph displays illustrative starting and ending blood pressure for the two groups. On the vertical axis, or y-axis, is the BP reading. On the horizontal axis, or x-axis, is group and time. This graph is an alternative way to depict the significant differences between the groups for ending systolic and diastolic blood pressure. The second graph displays illustrative monthly systolic BP over the course of the study. On the y-axis is the systolic reading, and on the x-axis is time. We see that Group 2 showed lower blood pressure at several time points. In Module 2, our second clinical question was whether varying exercise types for patients could lead to short and long-term changes in pulmonary function. We will use a case control study design, and our outcomes will include average FEV1 values and average SpO2 values. Our metrics will include average FEV1 values as a percentage of normal capacity and average SpO2 values as a percentage of oxygen saturation. The first table summarizes illustrative demographics for the two groups, clinically standard exercise versus progressively challenging exercise. As in the first example, we see patients' mean age, mean body mass index, and the percentage of males and females. The second table summarizes illustrative results from a logistic regression model to predict healthy FEV1. Patients with a progressively challenging exercise regimen had significantly greater odds of healthy FEV1, and older patients had lower odds of healthy FEV1. The first graph displays illustrative FEV1 for the two groups at week 1 and week 36. On the y-axis is the percentage of predicted capacity. On the x-axis is group and time. The second graph displays illustrative monthly FEV1 values and SpO2 values over the course of the study. We see that Group 2 showed increased FEV1 and SpO2 at several time points. In Module 2, our third clinical question focused on caregivers' experiences and collaborations when treating patients with lymphoma. We will use an ethnographic approach with exploratory, open-ended interviews digitally recorded and later transcribed. The interview guide will be designed by healthcare professionals, scholars, and caregivers. We will then read all transcriptions, develop themes, and produce final categories, with interpretive analysis to be reviewed by scholars to ensure validity. This table summarizes illustrative demographics. As in the two prior examples, we see family caregivers' mean age and the percentage of males and females. We also see caregivers' race by category and the proportions of family members affected by lymphoma. This table shows simplified narrative responses from one caregiver to questions in the interview guide. For perceived emotional consequences, this caregiver reported that it's been challenging at times working with a lymphoma patient, but very rewarding. The caregiver also reported that, although it's stressful, I'm confident I'll be able to care for my family member. And I have new empathy for people dealing with chronic illness. For perceived impact, the caregiver reported that the healthcare professionals I've worked with have been courteous and helpful, as well as I've learned to communicate more effectively with family members. In the next section, we will discuss how to write up the results for this and the other two clinical studies. Now we'll ask you to reflect on what you've learned. What is an appropriate format for reporting data trends? A graph is appropriate for depicting data trends or changes in patterns over time. What term refers to the vertical axis of a graph? Another term for the vertical axis of a graph is the y-axis, compared to the horizontal or x-axis. True or false, graphs are typically used to show qualitative data. The answer is false. Graphs are commonly used to show quantitative data, whereas direct quotations from subjects are often used to communicate qualitative data. This education series is made possible by a generous gift from the Stanford University School of Nursing alumni in collaboration with Stanford Healthcare, Lucile Packard Children's Hospital, and Stanford Medicine. Congratulations, you have completed the first section of Module 4.